Okay, so we're just on a little short topic called trig identities, and there are lots and lots of trig identities, but the ones that I want to cover today are just two of them. Okay, so just from normal Year 9 trigonometry, we've got sine theta is opposite over hypotenuse and cos theta is adjacent over hypotenuse. So just remember your SOHCAHTOA. Okay, so sine is opposite over hypotenuse, cos is adjacent hypotenuse. So in this first one, I want to see what happens when we just do sine over cos. So there's my division sign. So I'm dividing the two things, so I'm going to divide. So I've got opposite over hypotenuse divided by adjacent over hypotenuse. Now, that's a division sign, so I can flip division to a multiply, and then I have to turn the second number upside down. So when you divide, you multiply by the reciprocal, so opposite over hypotenuse becomes times hypotenuse over adjacent, and then the hypotenuse sides cancel out, and you're just left with opposite over adjacent. But over here, tan is the same as opposite over adjacent. So basically, there's a nice little trick. When you've got sine over cos, you have the same as tan. And if you just put on your calculator sine of 30 and cos of 30, you'll see that it equals tan of 30. You can do it on your calculator to get decimal answers. Have a go at that. And when you're ready, copy that down and come back when you're ready. Okay, so we're moving on to the next page for the second trig identity, which is a really good one. Okay, so I'm setting up a unit circle, so I want you to copy the unit circle down exactly like I had. So sine theta is the y part, okay, the y part of the line, and cos theta is the x part of the unit circle, and the unit circle is a radius of 1. So just copy that down, and when you're ready, resume. Okay, so here's the beauty of this one. So we've got a right angle triangle, and we've known Pythagoras for a long time. So we've got three sides of a right angle triangle. So the first side, the purple side, is sine theta, which is going to be squared, and I'm going to square cos theta squared, and that's going to equal 1 squared, which is the hypotenuse. Now, just as a note, sine theta squared in textbook is written as sine squared theta, but it just means the same thing. And so obviously cos theta squared is the same as cos squared theta, and 1 squared is 1. And that one is really great to use. You just have to know this one off the top. So sine squared theta plus cos squared theta equals 1. So if you put a number in, so for instance, if you have sine of 15 and you square it, and you have cos of 15 and you square it, the answer will be 1. But I want you to do it on your calculator and just show it, and then just make up any number. Like, it doesn't matter what the number is. Sine of 65.5 degrees squared plus cos of 65.5 degrees squared, the answer will be 1. But you can make up any number, but it's a really good one to know. So sine squared theta plus cos squared theta equals 1. And you just have to know when you see sine squared theta, it's the same as sine theta squared. Okay, sine squared theta is sine theta squared. Okay, copy that down and we'll show you how to use it. Okay, so here's one where you get one of the ratios, sine or cos. Okay, you don't normally get tan, but normally you get sine or cos, and you have to find the other ones. So I'm going to show you two methods. One method is using the identity that we've just done, and the second one is using a diagram. So just make sure we got so we got sine theta is 3/5. So I'll just write that down again. So sine theta equals 3/5. So we've got the identity, sine squared plus cos squared equals 1. So then take the sine squared across the other side and make some minus. And then to get rid of the square, you square root, but you have to take plus or minus. Okay? When you take the square root of the other side, you have to put a plus or minus in front. So then sine squared theta, so you put 3/5 and you square it. So 3 squared is 9, 5 squared is 25. And then on your calculator, 1 minus 9 25ths is 16 25ths. Maybe you could do that in your head. But we've got this plus or minus out the front all the way down. And then the square root of 16 is 4, and the square root of 25 is 5. So we've got cos theta is two different answers. It's a positive 4/5 or it's a negative 4/5, and when we do the diagram, you'll see why there's two answers. So if we've got two answers for cos, then we're going to have two answers for tan. So when cos is the positive, tan is, this is the sine over the cos. So tan is sine over cos. So we have 3/5 over 4/5. The 5's just cancel out. So you end up with 3/4. But when you had the negative 4/5, the other answer, because there's two answers, there's positive 4/5 and there's minus 4/5 for cos. And so when you do the calculation again, the 5's cancel out, so you end up with negative 3/4. Now, that may not make sense, but when, I think it must be on my next page. So on method 2, you could draw a triangle. So sine theta is 3/5, which is positive. So we've got all stations. So sine is positive in first and second. So if I do my triangle in the first quadrant, so there's my angle just there. So there's the opposite. So that number is the opposite side, and that number is the hypotenuse side. So there's my 3/5. And then use Pythagoras. You got a 3, 4, 5 triad. And so your cos theta. So in the first quadrant, cos theta is 4/5 and tan theta is opposite over adjacent. So that's why you get the first answers. Now, in the second quadrant, distances going this way will be negative. Okay, so this distance here is a positive because it's going to the right, but here this distance is negative because it's going to the left. And theoretically, if we were down here, we could have negative that way and negative that way, but we're not in that quadrant. Okay, so even though we've got a right angle triangle, we assign a value of minus 4/5, not positive 4/5. And so in the second quadrant, we know only sine is positive, so the others must be negative. So cos theta is the minus 4 over the radius 5, and tan theta is opposite over the adjacent, which gives us the other negative. So it gives us the same answer. Okay, so method 2, draw a triangle. It's not really a unit circle because the radius is now 5, but it's still a circle with quadrants. Okay, copy that down, and we've got one more page to go. So example 2, I'm going to show you both ways. So if cos theta equals 3/7, and we're told this additional information over here, whereas the first one we weren't told any additional information, find sine and tan. Okay, so sine theta, so we've got sine squared plus cos squared equals 1. So I'm taking sine squared equals 1 minus cos squared. And so sine will equal the square, plus or minus the square root of 1 minus cos squared. Now, I only need the positive number for the square root because I've got this thing here tells me that I'm just in the first quadrant. So 0 to 90 is just the first quadrant. And so I've got all stations, 2 central. I'm in the first quadrant, so I only have to worry about the first being positive. Okay, so I've just got, so I've got 1 minus cos squared, 1 minus cos squared, 3 squared is 9, 7 squared is 49. On your calculator, you get 40 over 49. Now, your surds may not be great, but the square root of 49 is 7, and the square root of 40 is the same as 4 tens. 4 tens are 40, and square root of 4 is 2. So the numerator, the top line, becomes 2 root 10. But if you just, if you got panicky and you just wrote square root of 40 over 7, okay, you'd still get most of the marks, but the square root of 49 you must know is 7. Okay, and then to get tan, we're still in first quadrant, so tan must be positive. So it's sine over cos, the 7's cancel out, so just left with 2 root 10 over 3. But using method 2, which is just to draw a triangle, okay, so we're in the first quadrant because it's 0 to 90. Cos was 3/7, so the adjacent is 3 and the hypotenuse is 7 of the unit circle, which is not a unit, but that's okay. And then just using Pythagoras, you end up with root 40, and then you can get sine and you get tan to be the same answers. And that's the end of that video, so I hope you enjoyed it.